we should be up here. I'm really sorry, but this stuff was all just kind of on our own. So that's supposed to go at the top of your paper wherever you are. I apologize. The front and the back kind of look similar. So a function is a mathematical rule. That little statement would make more sense right there. I'm sorry. For each input or x value, there is one and only one. So one and only one output. Okay. Our domain, and we talked a little bit about this last week, are our inputs or x values. And our range are outputs, oops, or y values. Okay. So when it says one and only one output up here, that's saying maybe if you have a function f and you get 4 when you output, if you put 2 in again, that same x value, and you get out -4, so you get out something different, that cannot happen. Okay, you cannot get out 2 different values for the same input. Okay, what questions do you guys have so far? No questions? Okay. Do you guys need a minute to write that down, or is it okay if I move on?
I need a minute.
All right. I'm gonna play with this thing and see if maybe, I'm sorry, I'm getting in your way. Wanted to see if I could see all of you at the same time while also having all the notes up on the screen. It kind of works. Oops. Okay, so you could also write down what's in the PowerPoint, just this definition of a function. That's essentially what's in this box right here. Okay, all right, so we're gonna go ahead and move on to how do I know if a rule is a function? So if you are given a graph, we can tell if it's a function if it passes the vertical line test. Okay, so you should be able to draw a vertical line through your function and it should only pass through one time. So you should be able to put your pen up and down on your graph and it should only touch the graph one time. Okay, so I'm going to draw out an example. Maybe we have an absolute value function. And we should be able to draw a line through our graph, a vertical line anywhere along the graph, and we should only pass through one time. Okay, what questions do you guys have about that? Okay, are you guys ready to move on?
Can you show another example of how we do that?
Yeah, so I'll give you a non-example. Is that okay? So maybe one that doesn't work. So this is a non-example. So if you had a function that maybe looked like this, or I guess it wouldn't be a function, but a relationship, a mathematical relationship that looked like this, and I drew my pen up and down through it. See how I passed through this relationship twice? Okay, whereas over here, I only pass through once. This could also be, if I have a line, like a y equals mx plus b line, I can draw a line, a vertical line through it at any point, and it should only cross through once. Okay. So here in the PowerPoint, there should be examples of functions. And they give a couple graphical examples, this absolute value, a line, a quadratic, and a square root function. And now we're going to talk about the ordered pairs, which are these guys down here, and I guess this table too. Those count as ordered pairs. Okay, so from the ordered pairs or a table, we should have no x values that repeat. Okay, so an example, we have a table with x and y values. We have -1, 0, and 1. And we look down this x column. Oh, and maybe it's the identity function. So everything on the y is the same, -1, 0, and 1. That would be fine. No repeating x values happen in that x column. -1, 0, and 1 are all distinct values. Okay, and you can see in the PowerPoint example, our x values are 2, 4, 7, -1, 0. Those are all totally different values. So that is a function. Apple, blueberry, banana, and cherry are all different. So that is a function. If we look at the teeny tiny table, -3, -1, 3, all of those things are distinct x values. So we have 3 examples of functions right there from a table or ordered pairs. Okay, what questions do you guys have about that section? Okay, so now we're going to talk about from the map. The map is this thing right here in the PowerPoint where we have little arrows from one bubble to another bubble. Okay, so in a map, you can tell if something is a function with no x values have more than one arrow coming from it. Okay, so if I have a circle here, and a circle here, and these are my x values, these are my y values, okay, and we have maybe 1, 2, and 3 in my x's, and maybe just 4 and 5 in my y's. That's possible. Let me fix this bubble so it's not as ugly. It has the same stuff in it. I just didn't like the way it looked. Okay. We have 1, 2, and 3 in our x values, 4 and 5 in our y values. So maybe 1 goes to 4, 2 goes to 4 as well, and 3 goes to 5. Now this is okay because each of the x values only has one arrow coming out of it. A y value can have multiple arrows coming to it. That's fine. But each of the individual x values can only have one arrow coming from it. Okay, so what questions do you guys have? Questions? Okay, do you guys need a minute to write that down? I'm going to assume that means no and that I can move on. Yell out if that's not true. So we're going to move on to non-examples of functions, okay? So we can have a function, maybe like a circular function or an oval. So maybe it passes through, go up 4 and out 4 on all the sides. We can make a little circle. I guess it's not a function, so I can't call it a circular function, but maybe we have a circular relationship between these points, okay? And if we draw a vertical line straight through here, we pass through 2 times, so we do not have a function there. Okay, maybe we have a rotated quadratic, so it looks something like that. This also, when we draw a vertical line through it, passes through twice. I'm going to go ahead and draw another example of if we have a vertical line, okay, a line like y equals 0, or I'm sorry, x equals like -4, okay? A vertical line is going to pass through this infinitely many times, okay? So a vertical line is not a function. Okay, so this is the definition of that vertical line, x equals -4. And a vertical line would pass through that infinitely many times, so we do not have a function. Okay, and maybe we have our map, and we have 1 to 4, 2 to 5, 3 to 5, and 3 to 6. What's the issue with this one, Brandy?
The three is going to the 5 and the 6, and it can only go to 1.
Exactly. So right here where we have 2 arrows coming from the 3, this defines this or forces it to not be a function. Okay. Good job. Okay, so the last little section is a you do. So you copy the problem and the answer yes, it's a function, or no, it's not a function. So number 1 has 2, 3, and I'm not going to force you to copy it down if you don't want to, if you feel like you have a lot of examples. 3, 5, 4, 1. So is this a function? And these are on the PowerPoint. If you have that open, and it's easier to copy it down from the PowerPoint rather than my terrible handwriting.